Uh, Good evening and welcome. So, as you can see, this talk will be about mobile C++ development for the most part, because initially this was actually supposed to be a talk about setting up a new C++ project before Harald convinced me to change the focus a bit. So I will also include a bit about that, but it's about setting up a mobile C++ project. So. Okay, so this talk, when I timed it, was a bit over 30 minutes with no questions, so you feel free to ask questions as we go along. We'll see how quick it goes. Also, I should say that we'll have a bit of an Android focus, because that's what I know. And also, I just noticed there's this term native that comes up, and it means two different things, so it can be confusing. Native, for me, usually means like native code, C++, C libraries, but in the mobile world, native means the platform you're on. So native can mean Java or Swift, depending on if you're on iOS or so. That can be confusing. So first thing, just a little bit about me. That's my GitHub page. I don't really have any Twitter or blog or anything, but most of my code is there, and my email is there if you need it for some reason. And I am a consultant at TreeTech, and I'm currently at Electrolux, where we're working on this mobile SDK to talk to large appliances like fridges and ovens and stuff, which I guess is why I get to talk about this. Also worked on the Android team at Unity before that, and I also have done some other weird mobile things that you can ask me about later if you want. So, mobile development, what do we mean by this these days? Okay, so this is not really it anymore, I guess. This was 10 years ago. There was a lot of stuff that could be mobile. Yeah, Symbian was fun. So now it looks like this, at least globally. So basically you only need to care about these two platforms, right? iPhone, Android. Unless, let's say you're developing for the developing world, or like places like India, where this looks very different. And in India, iOS is not even second place. But this is, for the most part, what we're going to do. Okay, so the development process then. So Android, this is Android Studio, which you use for Android development normally. And you write in Java or Kotlin, and Kotlin is a pretty nice language, especially compared to Java 7, which is what you need to use on Android still, which means that, for instance, you can't, if you write a list or a map, you can't really have an initializer. You need to create it first and then add each element one by one, which compared to C++, I mean, C++ is so much better. You build using Gradle, or Gradle is the stuff that Android Studio uses. You can build it from the command line or directly from Android Studio using a Gradle build file. And in this file, you can specify a CMake file to include, and it will just use that and build the native libraries and link those. And then you can call into this code using Djinni. And I guess some of you know Djinni. It's not that fun. And then a lot of the OS level stuff you still need to go back to Java to do, unfortunately. Except, well, sockets, you can use BSD sockets, you can use OpenGLES calls and sound, you can do that directly native. So for gaming, you can stay in C++ most of the time, which is nice. On iOS, you have Xcode. And I should say that, like I said before, I don't really know iOS that much. But you normally develop in Objective-C, or in our case, Swift. And you can link to native code using this thing called Objective-C++, which we'll get back to. You must use Xcode to build. You must use an Apple computer to build. At least the final step has to be on an Xcode on an Apple. But you can use CMake here as well. There's a pretty good open source tool chain file you can use that we also use. So so far so good. So do we have any other problems. We can use CMake, but what about the compilers? So Android and iOS, they both use R. They both use Clang these days. Android used to use GCC, or at least that was an option. Now they have deprecated that. And they both use libc++. So what's the problem? It should be easy. Well, maybe you want to write an app of some kind and you need a user interface. And then it gets hard because they're very different on Android and iOS. But that's not really related to C++. But I should at least mention that if you really want to do cross-platform UI development, these are the kind of the two options that people prefer. They're a bit different. Flutter is Google's thing. You write in Dart. React Native is Facebook's thing, and you write in JavaScript. So we're getting pretty far away from C++ here. And also, at least in Flutter, I know that you can't even call from Dart into C++. You need to go through Java. So it becomes very complex. I wouldn't recommend to do that. And besides UI, we have I/O and services, which, yeah, we're getting even further away from C++ here. But these are the kind of things that you sort of need to think about if you want to do cross-platform stuff. But more relevant to, at least to what we do is this problem, of course. The language binding. Actually calling the native code from the host language. This is assuming that you will actually have some part written in Java or Swift, and you usually need to have that. Okay, I'm getting low space warning here. Hopefully it will be okay. So, as I mentioned, on Android you use Java, Djinni, and on iOS you can use this Objective-C++, which is kind of a dialect of the mixes Objective-C and C++. But in this case, since we're using Swift, we can't really use this directly. Even if you have glue code written in Objective-C++, you need an Objective-C layer on top. And for Android, it's even more complicated. I don't know if you use Djinni, but basically you need to define C functions, and those functions needs to be named according to the class name they're used from. So you have to use it from the right class. You need to deal with the resource allocation. You need to manually allocate them free. It's very easy to get memory leaks. You need to handle exceptions manually. So it gets complicated. So then we come to this topic, which I didn't even consider at first. I was actually starting to write this Djinni stuff, and then I just happened upon this little project called Djinni, developed by Dropbox. That does exactly what we wanted, so it's very nice. You write your interface in an interface definition file, and you run this thing, and it generates all the glue code for both Java and Objective-C, and it also allows like bidirectional calls from both languages. So this was exactly what we needed. Like I said, developed by Dropbox, written in Scala. Anybody here that knows Scala? Yeah, I might. Good, Arvid. I might ask you stuff later. And it's now abandoned, so that's a bit sad. But it's a stable project. It's still on GitHub. Has a lot of stars and users. And as a trade-off, it's a small technical debt for us, and it does what it's supposed to do. Like the only sort of big caveat that we've encountered is it has a global object limit, so you can't really just create lots and lots of objects because you can sort of fill up this queue before the garbage collector has a chance to free everything. Okay, so this is what we have now. We have our application logic in C++. We have a way to call into it, both from Objective-C and in extension Swift, and from Android. And this is an image I stole from one of the talks about Djinni. There are a couple of talks from CVPCon that you can look at if you're interested in what Djinni is really. So everything is good, except now again speaking of Dropbox, there's this question that I've been hearing lately that comes from this, and it's this weird question. Should we actually do this? Should we share code between platforms? when we can? It's kind of a weird question, but it was spawned by this article. I don't know if you read it. Like, this summer, Dropbox announced, sort of related to them abandoning Djinni, of course, that they have given up on C++ entirely. They've gone over to 2 separate code bases for iOS and Android. And before this, they talked about how they used C++ to be cross-platform, and everything was nice. And this article goes into some details about why they made this decision. They say like the C++ supports standard library. It's hard to, since there's no good package management, it's hard to get the libraries you want, and that the IDEs like Xcode and Android Studio makes it so much easier because they do so much for you. But they also mentioned this problem, which I think is the real problem, and it's know-how. They had a C++ team, they moved on to other things, and they have large problems finding new C++ people. And this is true and sad, at least in my experience. It's hard to find good C++ people. So if you work in a company where you absolutely can't find any C++ people, yeah, well, maybe then you shouldn't write C++. And as for the other things that they mention in this article, the problem of finding libraries, I think that's not really true. There are a lot of really good libraries that you can just git clone and a couple of lines of CMake, and then you're good to go. And also the hand-holding IDEs, that's not always a good thing, that you can just click, build and run, and you don't really know what happens under the hood. But like I said, if you're not like a popular company, like a game company like King or Unity, it's going to be hard to find C++ people. But that I wanted to bring up this sort of counterpoint to the Dropbox story, and that's Unity. This is the Unity editor. I don't know if you know about this. This is a very popular editor for making games, especially mobile games. And Unity is what I would like to call a C++ first project. So they have a player that needs to run on, I think it's around 25 platforms now. So you can't really, write. Then you do C++. There's no real alternative. And they don't have bindings to jump into Java. They have the other way around. They have something called this Djinni bridge, which is an open source project. Can be interesting to look at. So what they do is instead they generate bindings from use reflection to reflect over the Java classes and generate functions that you can call from C++ instead, because they want as much as possible in C++. So that's the other way to do it. And also, and Dropbox never mentions this, this is what I think is a really huge benefit of having your C++ code shared, is that you can actually build on a PC. I'm not sure they ever did it, but in our case, I mean, that means that you get all these nice things that you don't get if you just have a mobile-only project. You can debug much better. You can use tools like Valgrind. You can benchmark. You have much quicker cycle times. You can sort of write code and compile and test really quickly. And you have this tooling bit here. I've written a command line tool for us that we can sort of use to check things. Like if someone says, like, hey, on this weird washing machine, if we send this temperature and do this thing, then this weird thing happens. Then I can just sort of simulate that really quickly and see if it's a problem with your configuration, or no, it seems like it's a problem for us. And then you can sort of debug it. So I think this is, if you do cross-platform mobile, you should really, even if it's not a mobile a project that fits on a PC, it's really worth making it work there. Okay, that was the first part of this. Now it comes. This is a bit more random. This is sort of the original talk or bits and pieces of it. So first, I should maybe go into a bit more detail about what the project on Electrolux is. So they already have this mobile SDK for communicating with these fridges, ovens, air conditioners, whatever. And it has been developed in parallel in Swift and Java by 2 different teams. And what I got to do when I started, or a bit after I started, was to start rewriting this in C++. So that's really, really fun to do. So this, but this begs the question, like, Electrolux, at least on this level, they don't have any guidelines or existing C++ code. I mean, they have for other departments, of course, they have. But this meant that I got to create this from scratch. So, but then the question is, like, with all these the new insights and things we know from modern C++, how can we do this in a way that gets everyone to agree that this is like the best way to do things? I really hope that we could have a coding standard that everybody agrees on. Sure. But I will talk about these few things here, at least. So first things first, I guess. Build system. It's kind of an obvious one, I guess. From what I've mentioned before, it's directly supported by Android Studio, and you can build on iOS. But I did look into alternatives. These, the Buck and the Bazel, which are kind of children of the Google Blaze build system, they have some really nice properties with, incremental builds that are sort of guaranteed to be correct. They use hashing instead of file dates and stuff like that. But in the end, we went with CMake. I mean, CMake, the support is, you can use CLI and Visual Studio Code and even Visual Studio these days. And even if stuff like Buck seems cool, I mean, we shouldn't go with a new cool thing unless you have a good reason. File structure. So I worked on a couple of C++ projects where they had very little in common when it comes to this. This seems to be completely random. So that's why it was nice when I read about this thing. Some of you have probably heard about this. It's a set of sort of guidelines on how to do a C++ project, and the sort of main article here is this project layout conventions. And it was written by this guy called Colby Pike, or otherwise known as Vector of Boole. I think he also did the CMake integration in Visual Studio Code. This is very nice. The start of this proposal starts with this comment, which I agree with. It doesn't matter, just be consistent. It has really harmed the C++ community more than it has helped. So he tries to sort of collect de facto standards and sort of best practices when it comes to how to lay out your directory structure. And we try to follow it for the most part. This is like a snapshot of our directory. It's not at all complete. And it's not very controversial, most of it. You have a source directory. You can have a separate include directory if you want. We choose to have the include files next to the CPP files. All your external stuff goes into external. Stuff that you can't really categorize are in extras. In our case, it's the definition file for Djinni. Also put the Djinni jar there so we can actually do this conversion without requiring extra tools to be installed. You have tests. You can have the test also next to the CPP files. We don't do that. The kind of 3 things here that are a little bit weird is that we actually have a make file. We also have these generated and precompiled directories, which are not part of the standard. And I can talk a little bit about this. The make file, this is because I really like when you can just check something out and just type make and it builds. So this is just a bootstrapping make file. I use something similar in a lot of my projects. The basic idea is, you check if you already have a CMake generated directory, then you can build. Otherwise, you need to run CMake. And it also takes care of putting the compile commands JSON file in the right place, which is this file you need for support in IDEs, IntelliSense and stuff like that. Precompiled libraries that you should avoid, but sometimes it's hard. So we have a few dependencies on things with custom build systems. We only have precompiled libraries for the mobile builds, and then it's kind of okay-ish because you know your target. You know that if you have a library, it will continue to work most of the time. So some examples here, we have curl, which use auto tools, an old kind of deprecated Internet of Things library called AllJoin, which is built using scons that we include as precompiled, but not on the PC build. I have AllJoin is built using an external project in CMake. What I will say about this also is that if I've tried very hard to make sure I have the origin of the library. So, I mean, there is a script that rebuilds this even for Android. We include the original source code for the dependencies with the patches that we have to apply. I've been in projects where you have static libraries that no one has any idea where they come from and who built them originally. And then if you want to do something like switch from 32 bits to 64-bit or CPUs, then that becomes not so good. Generated code. We check in our generated code, the code that Djinni generates, for a couple of reasons. One is that Gradle builds Java first by default, which means that when CMake runs and it generates a Java code, it's already too late.
Jonas, we have a question.
Oh, yeah, cool. Okay.
Question to the previous slide. Why not port the build systems to CMake and build those?
Sometimes you can do that. I actually started to try to do that with AllJoin, but it's a pretty complex thing. I still have to rewrite parts of the scons builds to get it to build with newer Android development kits. So nobody's really used it for a couple of years at least. Curl, I suspect, would be possible to I think they actually have a CMake file now, but it's not intended for inclusion in your CMake project. Yes?
Did you consider using a package manager like kernel?
Not really. I'd really like to have all the source code sort of available. Yeah.
You can do that. I think it's a really good use case here.
Yeah, maybe I should look into it again. But I don't think AllJoin is in kernel. So the problem is like the projects that you find in a package manager are often not that difficult to do anyway. But sure. Yeah, generated code. The other problem with that is that on iOS we have a kind of primitive build system currently that sort of needs all the source files to be available. So I think the first part there can be fixed. Actually, I don't think it's too hard to sort of modify Gradle to do it the other way around, but since we still have the second problem, we haven't done it. So we check in our generated code. Okay, this is next to last point, I guess, unit testing. This is an easy one. There was no real contention here. This is what I know and have used, and I didn't really see a reason to switch. Sometimes it's easy. So packaging, this is kind of the more mobile related part of this. So you built a native library, but you still need to consume them from in our case we have apps that are written in Swift and Android, and you need to consume this code somehow. And it gets a bit tricky. Android is Java, so that means normally you have a repository of some kind and you have your pre-compiled jars or AARs that you download, and that's hard. I think if you develop in parallel, you want to change code in Java and in C++ and try things. So for that we just use a sub-module instead. It works. Not so strange. For iOS we use a thing called CocoaPods. It's a Swift package manager. And we need to, that was what I mentioned before. It's kind of primitive, so we need to include precompiled libraries and generated sources and everything there. I don't actually know too much about how this process works, but it works for now. I would like to use CMake all the way on iOS too, but that hasn't happened so far. Code style. Okay, this is maybe even a bit more random. two things that I want to talk a little bit about: naming and formatting. So naming, long versus short names. So I'm curious here, who prefers the first version and who prefers the second version? You can get a little bit of time to read it. It's just basically it's the same code. It's just the name is changed. So show of hands, who prefers the first version and the second version? Okay, it looks like a C++ audience. Yeah, as you might have guessed, I also very much prefer the first version, but this is one of those cases where I had to sort of give in to what other people wanted. There's, yes?
Just a comment, this is so short code, so
yes.
If you was a long one.
No, absolutely. My argument is, of course, for short scopes, you want short variable names. If you want to name class that's used everywhere, you can sort of think about that for a week and like what is the actual perfect name for this class? It's really important. But there is also this other school that all names should be like explicitly describe what it is. You should never shorten anything. I think it comes from those people who've been unfortunate enough to sort of work with very junior programmers, and they're really scared that they will use a rule like this to just have short names everywhere, and they think it's safer to just say long names, long names, long names everywhere. But it's nice to see that we agree. So also for some things that when I was kind of developing this, I just went on CPP Slack and asked questions like this. So I guess most of you will be among the two top contenders here. So we can try this too. Who prefers M underscore for members? And trailing underscore. Okay, so this I don't think even half of you. So the rest of you, what do you prefer? We don't have no prefix at all or suffix.
The blue heart.
The single M. So it's kind of a mixed bag here, kind of like that. I actually went with trailing underscore, which I was not used to at all, but it seems to be kind of the thing. And also because I really like to get rid of that last remnant of the old Hungarian notation of M underscore. Snake case versus camel case. Yeah, I'm not going to say much about this except that I'm kind of on the fence about this, but we are generating Java code, and that's camel case, so it's going to be weird if so. And camel case is so far been mostly okay for C++ code as well, even if it seems like also the standard now is that you should have snake case for everything. And the last part of this part is formatting, and I'm just going to do this and say what we have done here. Clang format everything, spaces not tabs, 80 column limit. So who here agrees with all of this? And who has a problem with the 80 column limit? Yeah, that's what I figured. So I guess that when you think about this, this is kind of it goes together. I mean, if you have one of these, you usually want all of these. If you want a hard limit, you need spaces to guarantee your indentation. Otherwise, you don't know what 80 columns is. And this also goes together. To do this, you need Clang format to make this work for you. So the other side of this, I guess, is people who want hard tabs. They want their own indentation, and they want to decide when they break their code themselves. But I'm very much on the 80 column hard limit corner. Yeah.
If I may, you can have spaces and another number than 20.
80. Yes. Yes. Okay. We'll get to this then. 80 columns. If we break, why should we break at 80 columns? This was actually also supposed to be maybe a blog post or a short talk. I never finished, but I wrote this script. So the idea here was that you take C++ code, strip away all the comments, and you do the kind of logical breaks. You break after template, curly braces on your lines, but then you strip away all the curly braces. So what you end up with here is C++ source with only kind of C++ constructs that are normally things that you either break or don't break. And you run it through Clang format with like an infinite line length, and then you plot a histogram. And then you will see sort of, is there like a good cutoff point? Because you don't want to put the cutoff point too far to the right. You're going to have a lot of empty space. It's just pointless. And you don't want to go to short lines, because then you will have to break many lines and it becomes hard to read. So I'm not even considering the fact that many people say that you should have short lines because it's more readable. Like the idea that 50 to 70 short characters per line is what's, because that's to be fair, that's for text. For books, it's different for code. I think you can actually read longer lines when it comes to code. But anyway, I did this for just a few projects. And well, here this is for the popular JSON library. So here you can see that, yeah, around 80 seems to be pretty good cutoff. There's a lot of longer lines, but I mean, if you don't want to cut anything, then you better get up to 200 or something, and that's kind of ridiculous. But if you cut at 80, most of the lines will not be broken. Some of them will. And well, if you look at other projects, well, this is FMT. Here it looks more like 90 actually. So if you want to make a case for going a bit further up, I can understand that. And this is Lua, it's plain C code. Most lines are very short. Still looks like 80 is kind of a good place to cut. So that's my argument for 80 columns. If you yes.
I would actually argue against your 80 pretty strongly. Your data shows that if we assume that developers are not idiots, then the limit should be somewhere around 100, 110, because if they write code in a smart way, then they will break when they need to break the line. But
then you're on the team where you think you should decide yourself where you should break depending on readability, and not that you should have a hard limit and set that.
Sure. Well, no, not readability. It should be a soft limit between 80 to 110.
Yeah.
But some people want to have code side by side, multiple files side by side.
Yeah, there are many arguments here. You can. Arvid, you have a question?
How do you break for loops? Does each semicolon count as a statement and you assume you break them? Or?
No, I didn't break much at all. I only broke after templates and maybe one other thing. I don't remember now. But no, I didn't do any excessive breaking just to get the lines to be short. Yeah?
All the formatting of code, like enforce it somehow, like with a build system, or like...
We don't enforce it. It's still mostly me on the team. We have some consultants, but I'm mostly in control so far, so it's going to be interesting if we get to be enough people. But no, I'm not sure how you should do that. I mean, at Unity they had this pre-commit step that actually checked if the code was formatted correctly. Otherwise, it just told you, then you had to manually format. I don't know. Okay, so this is the last part. C++ 17. Our code base is actually C++ 14, and it's been that since the start. But so a couple of weeks ago, I decided it was time to go to C 17 because all the compilers has been supporting it for a while. And this is basically what happened. I spent a week doing this, and I reverted everything after a week. So that second point there, we have a lot of strings, so I thought that switching to string view would make things faster. It slowed things down. Can anyone guess why?
Created strings from string views.
Maybe. We have a lot of unordered maps. And unordered maps can only compare using the key type, not something convertible to the key type or comparable to the key type. So yes, this was not ideal for us, but it's going to be solved in C++20, I read, with transparent comparators, or what it's called. But that was actually not the main reason. It was more because of things like this. If you've seen this error message, I think this was maybe the kind of the drop, the major point. So this is what you get on if you try to compile it on Xcode 10.1 at least, I think. So as far as I know, what this means is that they have, in the standard library, they have included overline types, but they have not included the align version of new. So everything works until you try to put one of these types on the heap, and then you get a compilation error, which we do. Another more simple problem was this. Suddenly file system was not available anymore. And I thought, of course, nice, it's not experimental anymore. But for some reason, they removed it entirely in Xcode 10.3. It's supposedly back in Xcode 11 that came out, I think, a few days ago, but I haven't tried it. So that's the reason why we're now back in C++14 again. In conclusion, I don't have much of a conclusion, but basically just do what you normally do. See, it's still C++, even on mobile. The parts that are different does not have much to do with C++. Maybe stay as C++14 for now. Maybe have separate UI code. If you have an application with lots of UI, or it's tricky to have a cross-platform UI and C++ code in the same app. And maybe you don't use C++ at all if you have only UI with little local logic, but yeah. Thanks, that was it. Any further questions? Yeah?
What about documentation?
I should add that. We basically use / exclamation mark and use Doxygen. Doxygen is not so good, but that's what it is. I have some ideas around how to do that better, but so far. And also I try to write, I just have a docs directory and I put a lot of markdown files there with stuff that no one reads. Maybe I will read it when I forget how stuff works. Yeah?
What unit testing framework do you use?
Catch 2, but I jumped over that very quickly because it wasn't really.
Can Unity editor work on Linux, or is it on the Windows application?
There is a version of the Unity editor for Linux nowadays. I haven't tried it. There was a beta that didn't work well, but now supposedly it works okay. And it's if you want to develop for other things than PC, it's nice to have a good. So, yeah.
I have tried it. It works nice.
Good. It was a long time coming, but.
What is the call chain from Swift? You're using Swift, right?
Yes.
Yes. So is the call chain from Swift to Objective-C and then Objective-C++ and then C++?
Well, as far as I understand it, it's Objective-C, but Objective-C can be if you use this Objective-C++, that becomes the Objective-C layer. So you jump from Swift into Objective-C, but you can mix there, and then you go into C++. Okay. So it's similar to Djinni, but probably a bit easier. But it's not really my area. Yeah.
How far did you get with alternatives to CMake before you decided to?
Not that far, actually. I was kind of set on CMake until somebody at the office said I really should look into Buck. So I read up on Buck and just sort of I thought, that's really cool. And then I thought, well, not cool enough. Yeah.
If you both have the desktop UI, so to say, on PC, different platform, and also this mobile UI, what is your best experience to share code?
To share code? How?
To share the code base between the two desktop UI and the mobile UI.
desktop UI and mobile UI, I have not looked at how to share that at all. UI on desktop, I haven't done that in many years. Yeah.
The code in Java or Swift that calls the C++ code, do you think the C++ programmer should write that in Java or Swift, or should the C++ programmer provide a specification and then let the more front-end gear programmers do that?
Well, I'm not understanding. Do you mean who should decide the interface?
Like it glues everything together. Who in the team should do that?
Well, that's what Djinni does. This tool, you just define interfaces and it generates it for you, and you tell Djinni which parts you actually want to implement and which. So you say like this is an interface for a C++ class, so then it only generates an abstract base class for that, and you implement it. So that's most of the stuff you implement in C++. But for instance, if you want to have a callback object, then you can say this is something that also needs to be implemented in Java. Then it's an abstract class for Java instead, or both C++ and Java, and you need to implement it there. But it works really nice. You don't have to think too much about that. One problem with Djinni is it uses shared pointers for everything because it talks to Java with references, so there is a lot of shared pointers in our code. That's the price of doing business. Anyone else? No? Okay, thank you.